What's up, what's up? So in this video, I want to explain function notation and kind of like just go through some examples over here because I feel like some of the examples are specifically what get people tripped up on this concept. The concept itself is completely fine. All you really need to know is earlier in high school, you would look at equations of any sort of graph or a function pretty much, and they would look like this, right? All that has changed like later on in high school, typically in the second half, is that now instead of y, we literally just put f of x. And this makes sense. Essentially, we're making x go through a function. And that function is x being multiplied by 2 and adding 3 to it. So I kind of have a little chart over here. So you might be familiar with just like plugging in the values of x into the y, or like over here, and getting a y value. And then you make a table of values, right? Real simple stuff. So over here, this would be 3. And then it would be 5, and then it would be 4 plus 3, 7, and 9 plus 3, so, not 9 plus 3, but 6 plus 3, 9, so there you go. So, in this case, so I want you to kind of think about, first of all, you would say this as f of x, f of 0, this is what you would say as f of x. So basically, the idea that I want to get across is that this is basically just means x equals to 0, okay? So that would just mean this, right? And then you can just calculate that, so that's 3. So essentially, if you did every single calculation, and you just think of this as f of 1, as basically just x is equal to 1, and then you're just plugging in that value into the equation, then you're fine. That's all there is to it. So yeah, like all of these answers over here would be the same as over here, right? So 5, 7, 9, right? So yeah. Okay, so now I want to specifically get into some examples just because I feel like this is the place where people get tripped up. So I try to pick out specific ones that I think would kind of like confuse people. So this will kind of give you a deeper understanding of how this function notation works. So first of all, over here, this is question A. So essentially our x is 5 minus 3 in this case. What is 5 minus 3? That's also 2. So our equation, I don't know what exactly I'll call it, our function notation essentially would be f of 2, right? Makes sense. But you could also keep it as this over here, f of 5 minus 3, but that's literally just 2. So I'm just going to write that as 2. So yeah, it saves us some work later on. So all we really have to do here is just plug in x equals 2 into f of x, like our function over here. So I'm going to kind of briefly just set it up. I won't bother doing the math because I know you guys got that, but I'll just set it up. So yeah, there you go. All there is to it. So yeah. And yeah, you just do the calculation. Okay, here, it's the same concept. Now, all we're going to do is we're just going to have, I like to use these type of like second brackets, where we're going to plug in x equals 5 into our function. Right? So that would look something like this. Oops, yeah, second bracket. And we would subtract that by when the function is equal to x equals 4, right? So subtraction, open the second bracket, and then we just plug in the 4. Right? Oops. Yeah. I keep on doing that. It should be a second bracket there. Yeah. Okay, so that's pretty much how it would be. I'm just setting it up for you guys. From here, the math's pretty easy. So yeah. Okay, for this one over here, it's another thing that I want to bring up is that you have to think of this f of x as like almost like a separate term, right? Or something that's within a pair of brackets, essentially, right? So this is just when the function has x equal to 0, right? So we can just write that over here. So f of 0 squared minus 6, 0 plus 1, right? Yeah, yeah. And then I think this would be equal to like just 1 and then 1 times 4 times 1, right? So yeah, so I just want to get the idea across that basically you can also have like a multiplication of whatever you have inside of, or like whatever this function is equal to at x is equal to 0, right? So you'd have to do whatever's in brackets first, obviously, and then you multiply by 4, right? So yeah. Okay, here we have some other examples. So here we're given two functions, and now we're given something interesting. We have variables within our x, but I want you to keep that same idea that we had earlier when our x, so let me use like a different color here, perhaps. So our x for this part is 2 plus a, and our x for this part, for g, is 3a plus 1, right? So I want you to think of it like that, okay? So perhaps I'll also switch colors again. Perhaps green. Okay, so let me go through this question. So we have our f of x over here. So let's put that down. Perhaps I'll zoom in as well. So we're just plugging this in as x, right? Our x is over here, right? And once again, I like using these second brackets. You don't have to use these if you don't want to, but I like to distinguish between the round brackets with second brackets, right? With these like sort of like straight brackets. I'm not sure exactly what you would call them, but yeah. So minus our g of x, which is this, negative 6x, and then we just plug in this as the x, right? Yeah, so just go ahead with that. And just keep in mind that we have a subtraction over here, but our function over here has a minus. So remember, keep these brackets, keep these second brackets, keeps it nice and organized. So 6, negative 6, 3a plus 1, right? Yeah, so nice and easy, right? It's not too bad. And you may be asking, like, okay, when I actually like solve all of this, I don't get like a constant. I don't just get like a nice number, right? That's completely fine. You're gonna have an expression, right? You're gonna have something like, I can't do this off the top of my head, but basically you'd have something like, I don't know, something like 10a, you know, I don't know, like plus 5. I'm just making something up at this point. But this is what I'm trying to say, is that whatever answer you get from this, if you have like a variable in your answer, that's completely fine. Like that should be your final answer. Like for example, if you were to do all this calculation with, you do everything in this bracket, everything in this bracket, subtract the two, and then you get this somehow, right? Hypothetically, then this would just be your final answer, right? There's nothing to do from there. Can't really get rid of that variable. Okay, one last one over here. So this one I found kind of interesting because, I don't know, I just saw it pop up on some like grade 11 lessons of math. So, okay, so the way that this works, still the same idea. Our x for the f function is 2a, okay? And our x for the g function is 3a, okay? Yep. Okay, so now we're gonna plug it in. And we're gonna make these two just equal to each other. So it's nothing too complicated, honestly, but it's just one of those things when you first look at it, you might get a little bit confused and you might not know where to start, right? So, yeah, so 3, 2a plus 1, g 6 over 3a, sorry. Yep. And then, yeah, you just set this up, you know, maybe I'll just do this math real quick. Negative 18a. So you bring this to the other side, you can have like 24a, and then bring this one to the other side. Get something like this. Something about that doesn't seem right, but I think that should be fine though. Yeah, that's kind of weird actually. I didn't expect that as an answer, but it seems to be everything is correct here. We followed the theory, so that should be good. It's just kind of, it feels kind of weird when you get some other fraction as your answer, but yeah, should be fine. All right, so yeah, so that's how you, so that's kind of like an introduction to function notation and also some good examples of, yeah, some good examples of like how it's commonly used in like simple questions. Not really, I don't really go over word problems, but that's another important part. Perhaps I'll do that in another video. But yeah, I hope this video helped.